S2O7. And this is the compound that is called oleum. H2S2O7. It is used as preservative. Tetronsome 6 acid. This is one of the most important inorganic acid in chemistry. Preparation. It is prepared industrially by the contact process. It is carried out into several steps. Step 1. In the step 1, sulfur solid combined with oxygen gas to give you sulfur 4 oxide. This is the first product that is produced. In the step 2, sulfur 4 oxide then combined with oxygen to give sulfur 6 oxide gas. So sulfur 6 oxide is produced in step 2. In step 3, sulfur 6 oxide reacts with concentrated tetronsome 6 acid to form oleum. In the step 3, sulfur 6 oxide reacts with concentrated tetronsome 6 acid. This is sulfur 6 oxide reacting with concentrated tetronsome 6 acid to form oleum. This is H2S2O7, known as oleum. And this is another important compound in inorganic chemistry. Step 4. In the step 4, oleum is then dissolved in water to give 98% tetronsome 6 acid, which is the most useful acid that you have. At that concentration of 98%, oleum combined with water to give tetronsome 6 acid, and the percent of this is 98. So this is the acid that is being produced, which is tetronsome 6 acid. Tetronsome 6 acid. Physical properties. Its concentrated form is a colorless and viscous liquid. When they say liquid is viscous, that means it moves slowly because of the components of that liquid. Its concentrated form is corrosive and causes severe burns when in contact with the skin. That is the corrosiveness of tetronsome 6 acid. It causes burn when it comes in contact with the skin. 3. Its concentrated form has a great affinity for water. Concentrated form has a great affinity. That means it has a great likeness for water when it comes to its water loving. Tetronsome 6 acid. Chemical properties. It reacts with metals to liberate hydrogen gas, and that is one of the properties of an acid. Because of the fact that tetronsome 6 acid is an acid, so it has the tendency to react with metals to liberate hydrogen gas. 2. It reacts with bases to form salt and water, and that reaction is what is known as neutralization reaction. 3. It reacts with hydrogen sulfide to form sulfur 4 oxide, and to form sulfur 4 oxide, water and sulfur. And that reaction can be demonstrated as hydrogen sulfide reacting with H2SO4, which is the acid, tetronsome 6 acid. When it combines with this, it forms sulfur 4 oxide together with water and sulfur. Is a solid, is a liquid, is a gas. Is concentrated aqueous, and is also a gas. So this is the balance equation for that reaction. it acts as a dehydrating agent, and that is one of the most important use of tetrahydrosulfate 6 acid. But in that system, it removes water, and that is what brought about the dehydration. Dehydration has to do with the ability to remove water from a compound. Uses of tetrahydrosulfate 6 acid. What are the uses of tetrahydrosulfate 6 acid? 1, it is used as fertilizers. 2, it is used to manufacture pigments. 3, it is used in the purification of crude oil. 4, it is used in dehydration of nitration compound. That's to remove water from that system. Then 5, it is used as a drying agent, and that is applied during the industrial preparation of tetrahydrosulfate 6 acid, where H2SO4 is used as a drying agent. Questions designed for this topic. Question number 1. All sulfides are black except lead sulfide, zinc sulfide, mercury sulfide, iron sulfide. 2. Sulfur 4 oxide bleaches by A. Oxidation, B. Reduction, C. Decomposition, D. Decarboxylation. 3. The property of sulfur used in the extraction by the fresh process is its A. Allotropic nature, B. Low melting point, C. Non-metallic nature, D. Transition temperature. 4. The gas that smells like rotten egg is dash. 5. The substance formed when sulfur 4 oxide is passed into water is dash. Answers to questions. Question number 1. All sulfides are black except in the chemistry of sulfide compounds. It is known that lead sulfide is black. Mercury sulfide is also black. Then iron sulfide is also black. The only sulfide of sulfur that has a white or whitish color is zinc sulfide, which is white. So the answer to question number 1 is B, it is zinc sulfide. Question number 2. Sulfur 4 oxide bleaches by reduction because sulfur 4 oxide has the ability to release electron, not accept. So when it talks about oxidation, that's loss of electrons. Reduction has to do with gain of electrons. Since sulfur 4 oxide has the ability to gain electron, so it will bleach by reduction. Decomposition has to do with the breaking down of molecules, which does not fit in. Then carboxylation has to do with carbon and majority of organic compound. And since sulfur 4 oxide is not an organic compound, carboxylation also does not fit in. So the answer to question number 2 is C, since sulfur 4 oxide bleaches by reduction. Question number 3. The property of sulfur used in its extraction by the fresh process is dash, allotropic nature. Sulfur does not an allotrope, does not have allotropes. So A can never be the answer. What makes sulfur suitable in the fresh process is because of the low melting point. Because if the melting point is high, it will be difficult for sulfur to be extracted due to the binding forces holding the molecules of sulfur together. So the answer to question number 3 is low melting point, which is B. Question number 4. The gas that smells like rotten egg smell is only one gas that has the odor rotten egg smell, and that is hydrogen sulfide. Hydrogen sulfide is the only gas that has rotten egg smell. The substance, number 5, the substance formed when sulfur 4 oxide is passed into water is sulfur 4 oxide is an acid and a hydride, and you know that one of the properties of an acid and hydride is that they combine with water to form acid. So when sulfur 4 oxide combine with water, so this acid, which is known as Tetronsome 4 acid. So the answer to question number 5 is triazosulfate 4 acid. Oxidation and reduction. Oxidation and reduction is also known as redox reaction. What is oxidation? Oxidation is the process involving loss of electron. Reduction. What is reduction? Reduction is a process involving gain of electron.